So in this chapter, we are going to learn about propagation of sound waves. Production of sound. Sound is basically a form of energy that produces the sensation of hearing in our ears. Sound is produced due to vibration of objects, and vibration is the rapid to and fro motion of an object. This is to and fro motion. For example, when we talk about sound, this is human voice. Human voice is caused because of the vibration of vocal cords. Stretched rubber bands basically vibrates to produce sounds. Any kind of sound is a result of vibration, and vibration is a result of a rapid to and fro motion of the inside particles. Now, sound propagation requires a material medium. A material medium is necessary for the propagation of sound to travel from one place to another. Requisites of the medium must be elastic so that its particle may come back to their initial position after displacement on either side, that is, the particles are capable of vibrating about their mean positions. The medium must have inertia so that its particle may store mechanical energy. The medium should be frictionless so that there is no loss of energy in propagation of sound through it. Propagation of sound in a medium. Longitudinal waves. Waves in which the particles of medium vibrate about their mean positions in the direction of propagation of sound is called longitudinal waves. One complete to and fro motion of the strip forms one compression and the one rarefaction, which together constitute one wave. Sound travels in air in form of longitudinal waves. Actually, the longitudinal waves can be produced in solids, liquids, as well as in the gases. At compressions, the density and pressure of the medium is maximum, while at rarefaction, the density and the pressure of the medium is minimum. Transverse waves. The wave in which the particles of medium vibrate about their mean position in a direction perpendicular to the direction of propagation of wave is called the transverse wave. A transverse wave is composed of a crest and a trough. The position of maximum upward displacement is called a crest. This is basically a crest. And the position of maximum downward displacement is called a trough. This is the maximum downward displacement trough. Transverse waves can only be produced in solids and on the surface of liquids. They cannot be produced inside liquids and in the gases. Characteristic of wave motion. A wave is produced by the periodic disturbance at a point in the medium. Due to the propagation of wave in a medium, the particles of medium vibrate about their mean position and energy is transferred with a constant speed from one place of the medium to the other place. Some terms related to wave motion. First is amplitude. When a wave passes through a medium, the maximum displacement of the particle of the medium on either side of its mean position is called amplitude of the wave. It is denoted by the letter small a, and the SI unit of it is meter because amplitude is basically a length. Now, time period is another term. The time taken by a particle of medium to complete its one vibration from here to there. This is basically the distance, and time taken for the particle to cover this distance is called as time period. The SI unit of time period is second. Third is frequency. The number of vibration made by a particle of a medium in 1 second is called the frequency of wave. It is denoted by the letter F, N or V. The SI unit of frequency is hertz. The frequency and time period are related as F equals to 1 by T. That means frequency is inversely proportional to time period. Then we have wavelength. The distance traveled by the wave in one time period of the vibration of the particle of medium is called wavelength. It is denoted by the letter lambda and SI unit is meter because it is also distance. Then we have wave velocity. The distance traveled by the wave in 1 second is called its wave velocity or wave speed. It is the speed with which energy is transferred from one place to another place by wave motion. It is denoted by the letter V. The SI unit is meter per second because it is basically a velocity. Here we can see displacement time graph of a sound wave. Then we have a relationship between the wavelength, wave velocity and the frequency. V equals to F lambda, where V is wave velocity, F is frequency and lambda is wavelength. Then the speed of sound in different media. The sound of cracker is heard only a little later than it has exploded. That is when flash is seen. This is because the speed of light is greater than the speed of sound. Speed of light is approximately 3 into 10 to the power 8 meter per second, while the speed of sound is nearly 330 meter per second. So the speed of sound in a medium depends on the following two factors. First, the elasticity of the medium and the density of the medium. So velocity of sound equals to under root E by P, where E is elasticity and P is basically the density. The speed of sound is different in different media. The speed of sound is more in solids, less in liquids, and least in gases. These solids are much more elastic than liquids and gases. The speed of sound is nearly 5100 meter per second in steel, 1450 meter per second in water, and 330 meter per second in air at 0 degrees Celsius. Example showing that the speed of sound in steel is more than that in air. A person living near the railway track often presses his ear against the steel rail to guess whether a train is coming or not. The reason is that the vibrations produced by the moving wheels of train travel much faster through steel rail than through air. So the sound is heard through track much before it is heard through air. Thus the person, by hearing the sound through the steel rail, gets the indication that a train is coming. Factors affecting the speed of sound in gas. 4 factors are there. Effect of density. The speed of sound is inversely proportional to the square root of density of gas. Then we have effect of temperature. Speed of sound in a gas increases with the increase in temperature of gas. Effect of humidity. The speed of sound in air increases with the increase in humidity in air. Then we have effect of direction of wind. The speed of sound increases or decreases according to the direction of the travel of wind. Factors not affecting the speed of sound in a gas. 3 factors are there. Effect of pressure. The speed of sound in a gas is independent of pressure. Effect of amplitude of wave. The speed of sound does not depend on amplitude of sound wave. Effect of wavelength or frequency of wave. The speed of sound does not depend on the wavelength of sound wave. Comparison of speed of sound with speed of light. Speed of sound versus speed of light. Sound waves cannot travel in vacuum, while light waves can travel in vacuum. The speed of sound waves in air is 330 meter per second, while the speed of light waves in air is 3 into 10 to the power 8 meter per second, which is about a million times greater than the speed of sound waves in air. The speed of sound waves is more in solid, less in liquid, and still lesser in gases, while in the case of light it is just the reverse. The speed of light waves decreases in an optical denser medium, means it is highest in gas, lowest in solid. The sound waves in the air are longitudinal mechanical waves. The light waves are transverse electromagnetic waves. Consequences of the large difference in the speed of sound and that of light. Thunder and lightning. In the thunder, light is seen much earlier than the sound of thunder is heard, although they are produced simultaneously. But the reason is that light takes almost negligible time in comparison to sound in reaching us from the place of thunder, because the speed of light is much more than the speed of sound. Now the concept of infrasonic, sonic and ultrasonic frequencies. The audible range of frequency is 20 Hz to 20 kHz. The sound of frequency in the range 20 Hz to 20 kHz is called sonic or audible sound. The sound of frequency less than 20 Hz and more than 20 kHz is basically beyond the reach of audibleness of human ear. Ultrasound and its application. Properties of ultrasound. The energy carried by ultrasound is very high. The ultrasound can travel along a well-defined straight path. It is not bend appreciably at the edges of an obstacle because of its small wavelength. Applications of ultrasound. Second is that next is bats avoid obstacles in their path by producing and hearing the ultrasound. They produce ultrasound which returns after striking an obstacle in their way. By hearing the reflected sound, they judge the direction of the obstacle in their way, and from the time interval, they judge the distance of the obstacle, because the sound produced by bat is basically ultrasound. Now we have ultrasound is also used for drilling holes or making cuts of desired shape in materials like glass and hard materials. Now the next application is for medical purposes, for imaging the human organs. Ultrasound is widely used. Ultrasonography or ultrasound is used to obtain the images of patient organs like liver, gallbladders, uterus, etc. It helps to detect stones, tumors, and echocardiography used to obtain the image of heart. Another medical application is ultrasound is used in the surgery to remove cataract and in the kidneys to break the small stones into fine grains. Another application of Sound is in the marine world, that is in the form of sonar. Sonar is abbreviated form of sound navigation and ranging to detect and to find the distance of object underwater. Ultrasound is used. This is used to detect any missing aircraft or to avoid the danger of blue whales. That's all in this lecture. See you in the next one.